Hello everyone, and welcome to cancer cell classification with Python package cv2 and numpy and matplotlib. So before we start anything, I want you in your command line to write pip install opencv/python as you see in the screen. I'll put it in the description to make it easier. And then let that load. I already have it installed, but it'll only take a few seconds. And then when we're done with that, we're going to go into Jupyter Notebooks. And this will load up our IDE Jupyter Notebook. However, I'm going to post the link to this PNG file. This is the cancer cell the cancer cell picture that we're going to manipulate to then allow cancer cell detection. I believe the big purple ones are the cancer cell. We'll need this image for training. I'll post the link to it in the video description. Then we go back, and we're just going to create a Jupyter Notebook. Open up this one. Lessons. What do we call it? Just PNG. So this is only episode 1 because we need a lot of code. So we need to import 3 libraries. So import numpy as MP, then import cv2, then I'm going to say import matplotlib.pyplot as plt. Shift enter. If it runs fine, then that means everything is working. So numpy is a numerics processing library that allows us to create arrays. Matplotlib allows us to plot graphs, and cv2 allows us to manipulate images. And it's I think it's actually referred to as OpenCV, and there's a difference between cv2 and OpenCV. But cv2 allows us to read and write to images and manipulate them as we see fit. So we're going to create an object in Python called image, and we're going to set it equal to cv2.imRead parentheses. And in here, you're going to find where you saved the picture, / and the name. It is 120C, 120 PNG, Control A, Control C, and you paste that in here. Hold on. You put quotes, and you paste it in here. However, for every / you must change it to a \. And if you shift enter and everything is fine, that means it got to the file. And now we're going to convert the image to a grayscale image. So we're going to create an object called gray, and we're going to do cv2.cvt capital color parentheses the image, which is the object of the image, cv2.color in all caps. This is in all caps, so color, color underscore bgr2 gray parentheses. And then we're going to say cv2.imWrite parentheses gray.png comma gray. Shift enter. So what we did is we created an object called gray, and we set it equal to the previous image as all gray. And cv2.imWrite creates that image. We call it gray.png, and we give it what's to be created. So imWrite creates a picture called gray.png, and what picture of is of gray. And where I created this Jupyter Notebook is where the file is saved. So I go to Desktop, My Lessons, and here, gray.png, gray. And that's pretty much what we're going to be doing for this whole tutorial, is just creating images and yeah. Alright, so now we apply the median filter for smoothing. So we're going to create an object called blur m equal to cv2 dot median blur parentheses gray comma 5. And then we're going to do cv2 dot imRight parentheses blur m dot png comma blur m. Alright, so cv2.median blur with a capital B. And that should have created another image, which kind of blurs the image. So basically, we're creating multiple images that we're going to use to make the machine learning model, so to speak. Alright, so that was the median filter. So now we apply the Gaussian filter for smoothing. So we create an object called blur capital G equal to cv2 dot Gaussian blur parentheses gray comma in parentheses 9 comma 9 comma 0. Then we're going to say cv2 dot imRight parentheses blur g dot png comma blur m. And it returns true to say that this object was created. We have blur g, which is kind of just another, actually wait, blur m, which is basically another blur. And then we're going to create a histogram equalization picture. So we're going to call it histo norm equal to cv2 dot equalization equalize capital H ist parentheses and gray. Then we're going to do cv2 dot imRight parentheses. Let me just copy this object name so it's just easier to name it. png comma histo, another control V, true. And that's what the histo norm looks like. Okay, and now we're going to create a clay object for contrast limited adaptive histogram equalization. Yeah, what a mouthful. So we're going to create an object called clay that is equal to cv2 dot create clay CLAHE in all caps parentheses flip limit equal to 2.0 comma tile grid with a capital G capital S size equal to parentheses 8 comma 8. Then we're going to say clay norm equal to clay dot apply parentheses gray. Then we're going to say cv2 dot imRight parentheses clay norm dot png and just comma clay norm true. And this just yet again created another picture. And so what I hope you're seeing is basically we're creating different pictures of the same object at various stages of quality to help emphasize what we want to detect. And now we're going to define a function to match each intensity level to output intensity level. So we're going to say define, which is how we create a function, pixel val parentheses pix comma r1 comma s1 comma r2 comma s2. colon, and we're going to say if parentheses 0 is less than or equal to pix and pix is less than or equal to r1, we're going to say colon, return, parentheses, s1 divided by r1 times pix. Elif, which is just else if, r1 is less than pix and pix is less than or equal to r1, colon, return, parentheses, s2 minus s1 divided by parentheses r2 minus r1, all of this times parentheses pix minus r1 plus s1. And then else, if it doesn't meet any of these parameters, we're going to say return, or conditions, we're going to say return, parentheses 255 minus s2 divided by parentheses 255 minus r2 times parentheses pix minus r2 plus s2. Okay, so we're now going to define the parameters. I'm just checking that I make sure everything is right. Define pixel pix r1 s1 r2 s2 colon if 0 is less than or equal to pix and pix is less than or equal to r1, return s1 divided by r pix. Oh, I made a mistake. It's r2, not r1 here. See, that's why I was checking, because it's a lot of stuff. And then we return s2 minus s1 divided by r2 minus r1, parentheses, times pix minus r1 plus s1. Else we return 255 minus s2 divided by 255 r2 times pix minus. Okay, now we're going to define our parameters. We're going to say r1 equal to 70. We're going to say s1 equal to 0. We're going to say r2 equal to 200. Then we're going to say s2 equal to 255. Then we're going to vectorize the function to apply it to each value in the NumPy array. So we're going to say, we're going to create a variable called pixel underscore value, pixel capital value underscore vector equal to np dot vectorize parentheses pixel. So basically, we created a new function that is equal to NumPy vectorize a pixel or a few pixels together. So we're now going to apply contrast stretching. So we're going to create an object called contrast underscore stretched. I'm going to copy this to save space or save time. Set it equal to pixel capital value underscore vec, our function, and we pass in gray, comma r1, comma s1, comma r2, comma s2. And we're going to create another object called contrast stretched underscore blur m equal to pixel val underscore vec parentheses blur m comma r1 comma s2 comma r1 s1 comma s r2 comma s2. Then we're basically going to save these files. So cv2.imWrite parentheses quotes contrast stretched.png comma contrast stretched. I'm going to copy this again for blur mg underscore blur m Turn is not defined. I made a mistake. Turn. Oh, okay, that's what I did. Sorry. I made another mistake that I didn't even check. What did I do wrong? Name in code 3. There we go, true. Okay, so I had just one return function wrong. And so that should have created more files. So the contrast stretched this, and the contrast stretched blur mg is this one. And now we only have the cancer cells to work with. Whereas before it looked something like this. Now we just have the cancer cells. So now we're going to use edge detecting. We're going to get edge detecting using canny edge detector, which basically is a built-in function that will make it more accurate. The cancer, you'll see. Edge is equal. We create an object called edge. We'll set it equal to cv2 dot capital canny parentheses gray comma 100 comma 200. And I am just going to Control Z. I'm just going to copy this. And I'm going to say cv2 dot IamWrite parentheses quotes edge dot png comma edge. And we're going to copy and paste this because we're just going to make multiple. We're going to create two more. So we're going to create edge G, and that's going to be surprise blur G. We're going to say edge G, edge G. I'm going to create one more. It's going to be edge M or blur M. Blur G is not defined. Thought we did. Oh, it's lowercase. It's lowercase. Sorry about that. Edge M. Oh, okay. There we go. Sorry about that. There you go. So edge, edge G, edge M. And so here's edge, where it's in black and white. Then we have edge G and edge M. So basically it only has the edges, so it knows where to stop. Knows what is the cancer cell and what isn't. And thank you for that. This is episode 1, and I'll show you what to do next week for episode 2. Thank you.